Introduction to electron dot structures. We use electron dot structures to represent covalently bonded molecules and the way in which they are oriented in space relative to one another. Okay, so we don't use electron dot structures for ionic bonds, for ionic compounds, but more for covalently bonded compounds, where you will recall covalent compounds, the atoms share electrons between their atoms, whereas ionic bonds, there's a complete transfer of electrons. So if we just look at carbon, for example, we can go from carbon, which has 6 electrons. So carbon, if we go from the very beginning, so here's carbon, 12, 6. 6 tells me the number of electrons. If I go directly from this element representation, we've discussed the Bohr model. First energy level, max 2 electrons. Second energy level to make up the 6, 1, 2, 3, 4. We know that the outermost energy level tells us the number of valency electrons, which gives us a lot of information about whether the atom is going to bond ionically or whether the atom is going to get involved in covalent bonding. So if we look here, we see that valency equals 4 electrons. I'm going to use a little abbreviation 4. If we go from the Bohr model representation to the electron dot structure, also you guys, this is often referred to as Lewis electron dot. They're synonyms. Then we take our carbon atom and we imagine a little box around the outside, like this. And we, as scientists, agree that in order to show the electron dot structure for carbon, we are going to begin anywhere along the box, but we're going to go around the box once, and then if we have to come around again, we will. So let's take a look at carbon. 1, 2, 3, 4. Right? So we say that that is the electron dot structure for the element carbon. So if we now let's expand and take a look at, so we can do that for any atom. But let's expand that and let's go to CH4. This is methane, this stuff that comes out of the gas jet. When you do an experiment, you have to turn on the Bunsen burner. So if we were to sort of look at this from a Bohr model representation, all right, we would have this. We would have our 2. There's 4 here. 2 in there. Valency 4. Carbon lose 4 and become a plus 4? Probably not. Carbon gain 4 electrons, become a negative 4? Probably not. So the fact of the matter is, a lot of nonmetals bonded to other nonmetals form covalent compounds. Now let's look at hydrogen. Let me go to a different color for you here. Let's go back to yellow, and I'm going to draw our hydrogens. Here's a hydrogen. We know hydrogen only has 1 electron. And here's another hydrogen with 1 electron. And this is a lot of work to do these Bohr model atoms. And so we're going to abbreviate in a minute. So I've got 1, 2, 3, 4 hydrogens. So can you see here that the outer shell of carbon has 4 valence electrons? And what if carbon sort of decides to join that outer energy level of methane? What you have is, you have your carbon with its 4 valence electrons, and you have hydrogen Now, if I had to do this every time I was going to do sort of an atomic representation, that would be a little bit tough. So This is CH4, and you'll notice, look at carbon's outer shell. It has 8. And hydrogen sort of feels that effect of 8. And what we have here is we have a sharing of electrons. This is covalent. So how do we abbreviate that a little bit? Well, we go to the electron dot. So from our pattern up here, we're going to take our carbon. Carbon, by the way, is always a central atom. Hydrogen can't be a central atom. You know, it's only got one energy shell. It can only accommodate 2. So hydrogen will never ever be a central atom. So let's put our central atoms here, there, 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 and there. Now, still keeping in mind the idea of 8, we come here, I'm reversing my colors here, and we say, okay, hydrogen will donate electron there, hydrogen will donate electron there, hydrogen will donate electron there, and hydrogen will donate electron there. Now, the white one and the yellow one that I've given as electrons are shared between the carbon and the hydrogen. Same up here, and same here. So if you count all the electrons around carbon, voila, 2, 4, 6, 8. Yay, carbon's happy, rule of 8, octet rule. Atoms, when they react, like to get 8 electrons in their outer shell, whether they do it ionically or whether they do it covalently. Now look at hydrogen. It has 2 bonds. We know that hydrogen feels just fine with 2 because that's the max it can hold. So what we have is, we have a representation of methane in this electron dot structure, and what you'll learn coming up is actually that this arrangement will give you information about the actual structure of methane. So this is the electron dot structure that represents this work that we've done all along here. Now, very often you'll see that as you sort of move along in your studying, that often you will let a line equal 2 electrons. So let's talk about what a bond is. Let me start. Okay, a single bond equals 1 electron pair. You have to have that minimum for atoms to bond together. So here's an electron pair, single bond, single bond, single bond, single bond. So carbon has 4 single bonded hydrogens to it. Now there's also something called, you guessed it, a double bond. What do you think? If you guessed 2 electron pairs, you're right. And there's something that is called a triple bond, which is, as you might imagine, 3 electron pairs. Okay? Now, I want to do an example for you that involves let me stop there and just have it be a short one, and I'll come back with part 2 because I'm running out of room. How's that sound? Okay, everybody, part 2 to come shortly.